Hello everyone, Jeff here with some examples of limits and continuity. These will actually be the same slides we used in the limits video, except we're adding a piece. Because in order for a function to be continuous, one of the requirements is that the limit, as you approach the value you're interested in, must exist. Then some other things have to be true, so we can just add on to what we already know. Let's look at this function. This is just x plus 3. We may want to know about the continuity at the value x equals 3, which would be the vertical line here. Three things must be true. The limit as x approaches 3 must exist. We already decided in the previous video, since if we approach 3 from the left-hand side, the function is approaching 6. And if we approach x equals 3 from the right-hand side, the function approaches 6, that the limit does exist and is equal to 6. The second part here is that f of 3 must exist. It does. If we put 3 into this function, we get 6. And the third piece, in order for the function to be continuous at x equals 3, the limit as x approaches 3, which is 6, must equal the value of the function at 3, which is 6. So this function is continuous at x is equal to 3. The very informal rule is that a function is continuous if you can draw it without lifting your pencil from the paper, and you can see that you can do that. Nothing weird is going on at x equals 3. This function is continuous there, and in fact everywhere. Here's the very slightly different function, which factors into x plus 3, but because of the way we've written it, 3 is not in the domain, so we had an open circle here. Let's see what happens as far as continuity is concerned. We do start with the limit. We did decide as we are approaching x equals 3 from the left, the function approaches 6. And as we approach 3 from the right, the function approaches 6. The limit as x approaches 3 does exist and is equal to 6. Review the previous video if you need to on that one. Second of all, in order for the function to be continuous at x equals 3, f of 3 must exist. Here is where we have a problem. F of 3 does not exist. There is an open circle there. We can't put 3 in here because we have that domain issue. The denominator would be 0. And so this function is not continuous at x equals 3. It has a limit at x equals 3. It is 6, but the function doesn't exist at x equals 3, and so it fails the second bullet point here of continuity. A third example, this again very similar. We do have x plus 3, except we've defined it as being equal to x plus 3 for anywhere but 3, hence we have the open circle at x equals 3. And instead we've defined the function as being equal to 4 when x equals 3. So here we have x is equal to 3, the function will be 4. Checking continuity, we decided in the limits video that this limit does exist. As we approach 3 from the left, the function approaches 6. As we approach 3 from the right, the function approaches 6. So the limit does exist and it is equal to 6. Second part of continuity, f of 3 must exist, and it does. When we put 3 into this function, we do get 4. So we're okay there. The third part is the limit has to be equal to the functional value, and here's where we have a problem. The limit as x approaches 3 is 6, but the function is equal to 4 at x equals 3, and so this function is not continuous. The limit does not equal to the functional value, and again, if we use the informal trace the function without lifting your pencil from the paper, you can see that you can't do that. You'd go here and then stop and have to jump down here and then back up, so not continuous. And finally, we have another piecewise defined function. Here is x plus 3 again for x less than 3. If x is greater than or equal to 3, we have a different function, 7 minus x. In the limits video, we decided that this limit does not exist. If we approach x equals 3 from the left, the function approaches 6. But if we approach x equals 3 from the right, the function approaches 4. The limit doesn't exist, and therefore it cannot be continuous. The limit existing is the very first bullet point of continuity. So this is not continuous, and again, the trace the function thing won't work either. We would move along here, and then we'd have to pick up our pencil and go down here and continue. So not continuous at x equals 3.